Okay, so like I said, they're going to give you an equation that looks like this, and they want you to find the system of equation by graphing. Yes, I know it'd be way easier to solve for x using algebra, but we're going to solve using graphing because what we do the next few lessons is going to be adding on to this. Therefore, you have to know how to graph two different equations and check the solution. So we're going to graph that. So when we graph, we always want it to be in y equals mx plus b form, right? Okay. Do we have a y? No. No. Quickly.
Can we just add a y?
That's exactly what we're going to do.
Wow.
Okay, we're basically going to split the equation right here, and we're going to set both of them equal to y. So we would have y equals negative x plus 1, and then the other equation would be y equals 2x plus 5. Okay? Because we're not solving algebraically, we're solving by graphing. Okay, so remember when we did systems of equations, you had three possible answers. What was one of the possible answers? No solution. What did the lines look like if it was no solution? Because you have two lines, right? So they were parallel to each other if they're no solution because they never touch. What was another possible answer? All real numbers. And what did it look like if they were all real numbers? They were the exact same line. And then what was the other answer that we got? 1 point, and that point was where they intersect. Okay. So that's basically what we're doing again. Now that we have the two equations, all I have to do is graph them and then figure out what their answer is. So if I graph those two equations, I'm going to rewrite it over here. It's y equals negative x plus 1 and y equals 2x minus 5. What happened to my graph? Two equations, you have, what's the y-intercept on the first one? It's hard to see now. This one is 1, sorry. So I graph 1, and then my slope is negative x, so it would be
Down 1 over 1.
Down 1, right or left? Right 1, down 1, right 1. And then I would continue. The more dots that you put on your graph, the more accurate that's going to be. And then the other one, what's my y-intercept? So I put a dot at negative 5, 1, 2, 3, 4, 5. And my slope is, so I'd rise 2, up 1, rise 2, right 1. Okay, and then we see that they intersect at this point. So what is that point?
3 negative.
It's actually 2, I think, right here.
No, count again.
1, 2. So it would be 2, negative 1. But did I have a y variable?
No.
No. So my answer is just going to be the x. So what does x equal?
2.
So x equals 2.
That's weird.
Because we're only solving for x.
We never had a
did
y.
the
Because
thing
we
where
put
we
a
minus
y
all the x's and then just get the x equals 1, except it's more complicated.
We decided to have a y.
Yeah.
Wanted a Y.
You had to graph it so that you had a y. Yes.
We wanted a Y, we made a Y.
We had to have a y.
So wait, I'm confused.
2000?
Do you just need to find the x? There's no like.
That, my answer is just x equals 2.
Because the original.
Yeah, the original.
Oh yeah.
And that's where it is again. That's the one that we just did.
It answers 2.
Okay?
Don't look at me.
Did you use all of your graphs on the, okay, so AJ is going to pass out the graphing paper right here. Everybody use one of those again? Absolute values, like the absolute value of x equals 5. What were my two solutions for x?
5 and negative.
X could equal 5 or x could equal negative 5. So absolute values had how many solutions?
Two.
2. Okay, same thing goes when we solve for these in our systems of equations,
Four solutions.
except for we're going to have
Two solutions.
2 systems of equations, and each system of equation has 2 equations. So technically we'll end up with 4, but you only graph 2 on one graph and 2 on another graph. So what I mean by that is I would set this side, x plus 1, equal to the positive, which would be 2x minus 4, which is what you guys did when you did the absolute value of 5, right? You set that equal to the positive. So that's what I did here. So from this part, what would the 2 equations that I would get to graph? AJ?
Y equals x plus 1, and then y equals 2x minus 4.
Right? And then I also have to set my absolute value
Negative.
equal to the negative, right? When we did x equals negative 5. So this would be x plus 1 equals
Negative 1.
negative of this. So it would be negative and then everything. So the reason why Kit got it to be plus 4 is because it's the negative of the whole thing. So you distribute your negative. Negative 2x plus 4. Everybody good with that? So now the 2 equations that I get from this one is
Y equals x plus 1 and y I can't.
Negative 2x plus 4.
Question.
Yeah.
If we're, are we only switching that one to negative, like the second one?
You
why
can-
not? Why not the x plus 1?
you can choose which one you want to set to the opposite, but only do it to one of them. So we wouldn't do the negative of x plus 1 equals the negative of that. That wouldn't happen. So you could have set this guy equal to the negative, that's fine, and kept the other one positive, but just one of them.
Just keep one of them.
Yes. Okay? And you have to keep it consistent. So whatever I did to this one, I have to keep it consistent here. Okay? Questions?
Not yet.
So then I would just graph these on 2 separate graphs. So the pink equations would go on one graph, and the blue equations would go on the other graph. So let's see if I can find my graph. Yes, I do.
Like on our thing,
Yes.
that's kind of weird.
What's kind of weird?
The,
Yeah, I'll write the. If I graph the first set, which was the y equals x plus 1, what's my y-intercept? 1. And what's my slope?
1 up.
Up 1 over 1, up 1 over 1. And again, the more dots you put, the more accurate your line's going to be. And then the other one for that is what? Yes. Because we're still doing the same thing but graphing. So my other set is y-intercept was. So I graphed negative 4, and then my slope was up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, that's where they intersect. So at this point right here, I go over 1, 2, 3, 4, 5, comma, 1, 2, 3, 4, 5, 6. So one possible solution for x is what?
5.
So I would say one possible solution is x equals 5. Now we have the other set of equations that we still have to graph. So if we graph the other set, we still have x plus 1, so you still have the same y-intercept, the same line. And then your other one was y equals negative 2x plus 4, so my y-intercept is 1, 2, 3, 4. Yep, and then my slope is,
negative 2.
so I go down to over 1, and I already hit 1. Down to over 1. So this coordinate point is 1, comma 2.
Yeah.
So then my other answer for x is 1. So my final answer is x equals 1 or x equals 5.
Wait, wow.
What is that? Oh, you don't write one.
Yes, you only write the x value, not the y value.